Space, the final frontier, a vast expanse that stretches beyond our imagination, filled with wonders and secrets waiting to be uncovered. It beckons us with its mysteries, its beauty, and its promise of discovery. The allure of the unknown has always driven humanity to explore and push boundaries. But reaching for the stars comes with a hefty price tag. The financial and technological investments required are immense. Venturing beyond Earth requires cutting-edge technology, complex engineering, and a tremendous amount of energy. Each component must be meticulously designed and tested. All of these factors contribute to the high cost of space exploration. The journey to space is not just a physical one, but also a financial and logistical challenge. For decades, the dream of space travel seemed accessible only to governments and their massive budgets. But times are changing. The landscape of space exploration is evolving. Private companies like SpaceX are leading the way, developing innovative technologies that are making space travel more affordable. They are revolutionizing the industry. One such innovation is the Falcon 9 rocket, a symbol of modern engineering and ambition. The Falcon 9 is a marvel of engineering, a partially reusable rocket that is capable of carrying payloads into orbit and beyond. Its design is both efficient and groundbreaking. But even with its groundbreaking design, the cost of launching a Falcon 9 is substantial. Each launch involves meticulous planning and significant resources. Understanding the intricacies of rocket science, manufacturing, and logistics helps us grasp the true cost of reaching for the stars. It's a complex and demanding process. This journey takes us behind the scenes, exploring the various components and processes that contribute to the overall cost of launching a Falcon 9, from initial design to final assembly. From the rocket's construction and transportation to its fueling and launch, we will uncover the complexities and expenses involved in making space travel possible. Each step is a testament to human ingenuity and determination. Space missions are expensive. They always have been. The reason is simple. Space is a challenging environment to operate in. The distances are vast, the temperatures are extreme, and the vacuum of space is unforgiving. Building a rocket that can withstand these conditions requires advanced materials, sophisticated engineering, and rigorous testing. These processes are time-consuming and labor-intensive, driving up the cost of development and production. Then there is the cost of launching the rocket. The immense power needed to escape Earth's gravity requires a massive amount of fuel. The fuel itself is expensive, but the logistics of storing, transporting, and loading it onto the rocket also add to the overall cost. Furthermore, space missions require a dedicated team of engineers, scientists, and technicians. These highly skilled individuals play a critical role in designing, building, testing, and operating the spacecraft, and their expertise comes at a price. Despite the high costs, space exploration offers invaluable benefits. It advances scientific knowledge, drives technological innovation, and inspires future generations. By understanding the factors that contribute to the cost of spaceflight, we can appreciate the magnitude of these endeavors. The SpaceX Falcon 9 rocket stands as a testament to modern engineering, a symbol of human ingenuity and ambition. It is a two-stage rocket meticulously designed to transport payloads into orbit and beyond, pushing the boundaries of space exploration. But let's break down the major components of this marvel and understand their contributions to its overall cost, piece by piece. At the heart of the Falcon 9 is its reusable first-stage booster, a revolutionary feature in modern rocketry. This stage houses 9 Merlin engines and the majority of the rocket's fuel, providing the initial thrust needed to lift the rocket off the launch pad, a critical phase of the mission. The booster's reusability is a key factor in reducing the cost of subsequent launches, making space more accessible. Next, we have the upper stage, responsible for carrying the payload to its final destination, whether it's a satellite, supplies for the ISS, or a deep space probe. This stage is powered by a single Merlin engine optimized for vacuum operation, ensuring efficient travel through the void of space. While not reusable like the booster, the upper stage plays a critical role in delivering payloads to their intended orbits, ensuring mission success. Protecting the payload during ascent is the payload fairing, a clamshell-like structure that sits atop the rocket, safeguarding its precious cargo. This aerodynamic cover shields the payload from the intense forces and heat generated during launch, ensuring it remains intact. The fairing separates into two halves once the rocket reaches a certain altitude, revealing the payload and allowing it to continue its journey. Each of these components requires specialized materials, precision engineering, and rigorous testing, all of which add to the complexity and cost. The cost of these components, combined with the extensive research and development involved, contributes significantly to the overall cost of the Falcon 9, making it a true modern marvel of engineering and innovation. Section 4, From Coast to Coast, the Falcon 9's cross-country journey. Building a Falcon 9 rocket is a complex process that involves multiple facilities across the United States. The rocket's components are manufactured in different locations and then transported to the launch site for final assembly. This logistical undertaking adds to the overall cost of a Falcon 9 launch. The Falcon 9's first stage booster is manufactured at SpaceX's facility in Hawthorne, California. Once completed, the booster embarks on a cross-country journey to the launch site at Cape Canaveral, Florida. This journey typically involves transporting the booster by truck and barge, a complex operation that requires careful planning and coordination. Meanwhile, the upper stage and payload fairing are manufactured at SpaceX's facility in Texas. Similar to the booster, these components are transported to Cape Canaveral for final assembly with the rest of the rocket. The transportation of these massive rocket components is a significant logistical challenge. It requires specialized equipment, permits, and security measures. The costs associated with transportation, including fuel, insurance, and personnel, contribute to the overall expenses of a Falcon 9 launch. Section 5. Rebirth of a rocket refurbishing the Falcon 9 booster. One of the most groundbreaking aspects of the Falcon 9 is its partially reusable design, which has revolutionized the space industry. After successfully delivering its payload to space, the first stage booster can return to Earth and land, either on a landing pad or a drone ship stationed in the ocean. This capability is a game-changer in space technology. This reusability factor significantly reduces the cost of subsequent launches, making space missions more economically viable. However, refurbishing a recovered booster requires a dedicated team of engineers and technicians who specialize in this intricate process. The booster undergoes a meticulous inspection process to assess any damage incurred during launch and landing. Every inch of the booster is carefully examined. Components are inspected, tested, and replaced if necessary. This ensures that only the highest quality parts are used. The refurbishment process involves disassembling certain sections of the booster, inspecting and cleaning each component, and replacing any worn-out parts. This step-by-step process is crucial for maintaining the integrity of the booster. This meticulous process ensures that the booster meets the stringent safety standards required for spaceflight. Safety is always the top priority. Once the refurbishment is complete, the booster undergoes a series of tests to verify its readiness for another launch. These tests are comprehensive and thorough. These tests simulate the extreme conditions the booster will experience during flight, ensuring its reliability. The booster must perform flawlessly under these conditions. The ability to reuse the booster significantly lowers the overall cost of subsequent launches, making space travel more accessible. This innovation is paving the way for a new era in space exploration.